Moving on, our next presentation explores the adoption of CIS Benchmarks with a focus on how you can use their guidelines to harden your multi-cloud environment. I'm pleased to welcome Sean Atkinson, CISO of the Center for Internet Security.
Hello and thank you. This is Sean Atkinson, CISO here at the Center for Internet Security. From a cyber risk perspective, wanted to look at current threats and remediation in cloud security. So I wanted to bring you a presentation and a perspective today on these issues that we see permeating cloud security. One of the elements that we look through in terms of the multi-cloud era, and I believe we've entered into that era as we speak. We look at the multi-cloud era affecting many organizations due to underlying complexity. Really, we're seeing a growing number of organizations, recent polls looking at 60% of large organizations in the multi-cloud space, utilizing either one or more cloud services concurrent with the original cloud adoption that they had used a number of years ago. So one of the things we need to do is really ask this question, is how are we addressing both the requirement and need for cloud security in the multi-cloud era? We have our little word cloud here, and we're looking at elements of data, complexity, security, compliance, building abilities to assess not only a capability in the shared security model, but our approach to the management of our infrastructure on two different or even more services. Now that takes us into different areas. We look here at the underlying landscape. So one of the things that we introduce is both scalability and flexibility in terms of our cloud. So we have amazing advantages with utilizing cloud capability. But one of the things that, representatively from a CISO's perspective is the vigilance with respect to risk. We have a lot to consider in this space. We're looking at, elements of malware, crypto mining, staffing shortage, tool sprawl, all within the context of cloud security. We take that proposition and we look from a cyber risk perspective. So ultimately, we're looking at multi-cloud implementations, offering elements of resiliency so we can reduce our risk by utilizing the complementary capabilities of multi-cloud. So we can diversify our risk across providers, but it also introduces elements of complexity that then can contribute in other forms, risk to our underlying security posture. So we have to have a balance in terms of our approach. So we want to utilize the capabilities in order to strengthen our organization, but also understand that risks are part of this process that we need to calculate. We need to understand, quantify, and really bring to and highlight ultimately our approach. So when we say it complicates security management, so the element of complication is due to the underlying complexity where we see differing policies, security controls, potential gaps where we may have a configuration with a respect to an underlying virtual network within their respective organization's AWS distribution. Compare that back to our Azure distribution, they may not be apples to apples. So we have to understand the differences between the two to provide the same level of security posture. We look at data transfer vulnerabilities, and we look at those as elements of how are we managing the data flow between respective environments. Are these interconnected? Are they just two separate cloud environments that we're using for potentially different capabilities and services? We have to understand then the compliance standards that relate to each. Approach those with a contextualized element of understanding our risk so that we can work with, respectfully, the providers in our shared responsibility model, looking at what challenges both present, necessitating robust dynamic security strategies. The reason for robust and dynamic is there is a lot of change within these environments. There's such innovation within the cloud space that it's hard to keep up with the number of different types of capabilities that exist. But we want to effectively manage our cyber risk within these areas by approaching each with a contextualized approach. We can use our compliance standards in order to give us direction. But let not that be in the case of providing pure security control over these environments. It's not done for compliance sake. Out of good security, the byproduct is compliance. So when we address the evolution, one of the things the Center for Internet Security offers is the CIS hardened images. So these are virtual machine images hardened in accordance with CIS benchmarks. This becomes vendor agnostic. It's internationally recognized in terms of these are secure configuration guidelines. It gives us an opportunity to build the foundation of cloud infrastructure on a secure footing. So utilizing the hardened images provides both secure, on-demand, and scalable compute. That allows us then to have confidence to move forward. We can contextualize and we can build upon that security with the infrastructure that we're putting in multi-cloud environments. And the hardened images are offered across all major cloud service providers. So as I mentioned before, we see this velocity of innovation, and so we need to address the dynamic approach. We want to start secure, maintain secure, and build secure all the way into the future. Dynamically, we have an environment where operational expenditure allows us to create and manage security capability. It allows us to manage compute, storage, and a plethora of underlying capabilities that we want to enhance and use that utility, but we need to have security as part of an adaptive plan. We want that adaptation and dynamicism to be used in terms of building out capability to reduce our overall risk and exposure of our cloud assets. We're starting with a secure foundation. As mentioned, the hardened image is the start of that particular program. When we look, though, at the current state of cloud security, we're looking at primary security threats in the cloud. Over the last few years, misconfiguration, insecure APIs and interfaces. We've got unauthorized access to infrastructure. We've got distributed denial of service attacks and data breaches and data loss. Now, there are combination plays in terms of the tactics, techniques, procedures that are used to basically undermine the security that we have in these environments. So when an organization is faced with not one environment in terms of cloud security to control, manage, and provide risk mitigation strategy, when we multiply that, obviously that contributes to the threats growing across these particular platforms. And you're going to have particular platform parenthetic threats that may exist in one cloud service, but not the other. So that's where we also need to contextualize our control program to be able to react and respond as we see cyber threat intelligence, awareness from vendors in this space in terms of the controls that we need to apply, but also need to maintain that vigilance. We have to have an ability to understand our risk and exposure, introduce the right capabilities at the right time, so that we're managing environments that may be independent, but we're managing them to the same level of exposure. Now, in some cases, we may have, and we'll move on to the elements in this space, but I want to bring up one point of context, is that we may have certain infrastructure in the cloud managing information, data, processes that are a lot higher classification than maybe another cloud service, right? If we've got two independent cloud services. So it's not set it and forget it in that case, but there then gives a contextualized approach to understanding the exposure risk in both environments, where we want to contribute those respective controls, where those risk mitigation strategies need to be addressed in terms of us understanding the exposure, the data classification, the data management, and also the underlying configuration of those environments. But with the hardened images, as long as we start with that secure foundation, we can move to new levels of security compliance and control with that capability. It allows us a platform to build security no matter the underlying context of that environment. Hardened image for any underlying service or product is going to be where we need to introduce a capability that can be sustained over time and mitigate threats and risk. We have some major threats identified here. I'm going to start with data breaches and data loss. And in some cases, you'll have accidental deletion, human error leading to unintentional deletion. We have to look in terms of training, the underlying roles and responsibilities that we're providing in these spaces. And remember, the complexity is increased because we can look at the underlying controls that we're provided in the shared responsibility model. Gives us a lot of telemetry, a lot of capability in this space to understand how the system's being used, as well as how we control it. But adding those extra layers of complexity may in turn be a risk itself. Are we able to manage and understand this through appropriate cloud security engineering practices to manage access to representative data stores and underlying compute capability? We obviously then move into the malicious element of intentional destruction. Could be from a disgruntled employee or part of a cyber attack strategy. Want to build, as mentioned, the telemetry in the space and a massive amount of innovation in this area. It's good to have innovation in the space, but it's even better to be able to react to that through the dynamic processes, to be able to utilize that telemetry in order to inform when we see activity beyond an underlying baseline or where we see elements of attack. We need to be able to react and respond in kind. Getting that real-time telemetry through underlying system calls is going to allow us an ability to understand and manage these processes at a lot greater level. The problem there, the underlying risk, though, you have to have the underlying resources to be able to react to these elements. We can set up all the monitoring in the world, but if we're not able to react to that monitoring in kind and in time, basically not worth setting up in the first place, not worth expending those resources if there is no one behind the scenes to be able to react. And sure, we could use underlying functional capabilities and we could use Lambda and functions in Azure in order to do automated response and strategy, but we still need the person behind the screen, hands-on keyboard, and able to react and understand those processes for both escalation purposes and also management of the underlying responses. We look at service outages and we look at downtime or failure in that space leading to temporary or permanent data loss. We would want to address through both continuity and recovery plans in terms of our point objective, time objectives. How can we utilize these services to meet those when we're faced with adversary loss in this area? Allows us to move on into distributed denial of service. And here we'll see, traffic volume increases. And with the cloud, we have a scalable, elastic processes that can respond to increases in volume and traffic. But we want to look at the sudden massive spikes again as part of that monitoring process, leading us to respond. Can this lead to ultimately the service outages that lead to a data breach or data loss, as we mentioned previously? We can look at specific targeted of resources in this area where we're looking at key components as part of our networks, our applications, the underlying server and compute that's hosted in those areas as well. So it builds a monitoring program, identifying respective assets, being able to provide the telemetry back, where we can then use, ultimately, there are elements of complexity and scale, where we have a distributed nature of the cloud. And distributed denial of service, again, can be more complex and harder to mitigate, but with the tools and the right action plan in play to understand that this is a risk. So we want to have an incident response plan that we can utilize that will allow us to respond in kind to these certain situations. And we may even use elements of chaos engineering to introduce this type of strategy to our organization in a controlled manner. Managing that blast radius allows us then to approach a response plan in these particular instances and react, as it were, more appropriately when we see such activity. We look at the exploitation of vulnerable points. So attackers may exploit underlying specific vulnerabilities in the infrastructure in unsecured APIs, which we'll talk about shortly. And then underlying, that's the poorly configured cloud services. So we want to start secure, get that configuration to a level that's hardened, allows us to build on top of those activities in that space. We look at unauthorized access in terms of weak authentication methods. We look at lack of multi-factor, inadequate access controls, our insider threats, and misconfigured cloud storage. Each one of these elements looks for and is basically exploitable as the weakest link within a respective compartmentalized approach to security when we're thinking about authentication, where we're thinking about the access control from a roles, groups, and permissions perspective. when we're looking at even when those controls are set up, there are insider threats, whether legitimately it's a mistake or where there's malicious intent, that there are certain controls that are bypassed with the insider threat proposition that we have to review as part of our risk profile. We look at misconfiguration, and again, in the space of cloud storage, where we're inadvertently exposing certain data to the public internet, leading again to unauthorized access, where we have inadequate respective configuration plus underlying access control. So we want to build a layered approach, and this is obviously something we would heard, but defense in depth permeates into the cloud as well with all the services and the underlying capabilities. We want to build that ability to approach our risk based on the context of the underlying processes, services, and products we're consuming, and also utilizing the cloud for. It allows us to respond with a much more approach that leads us to thinking about our attack surface. So when we look at our attack surface in terms of insecure APIs and interfaces, we look at the increased vulnerability to attack. What are we doing in terms of managing our application programming interfaces? Are there flaws in basically the communication and the configuration in terms of how those APIs are executed and used within an organization? Can they be used themselves without limiting in terms of denial of service? Can they be used to execute other malicious activity, be a staging point in terms of a much greater plan in terms of a threat vector? And then potentially, ultimately, can compromise the entire cloud infrastructure. We also want to look here in terms of the transportation of information through lack of encryption. So with inadequate encryption in API, obviously, there's an ability here to expose data to interception. And again, that's leading us back to where we see the data loss pieces, the insecure configuration, this exposure element. We want to assess our exposure from the risk perspective as well, understand what could be exposed in these areas. Basically, we have to treat in kind, look at a control plan that can address that risk where we see sensitive information being processed, managed, stored, and controlled. We want to have the respective telemetry to understand, are those controls effective as in play? We have the API dependency and third-party risks, where we're looking at third-party APIs. What vetting are we doing with respect to those APIs in terms of vulnerability and our dependency on those? Because we can look at the cloud infrastructure and say there is a permeating dependency across our cloud assets, right? We're reliant upon the cloud service provider to keep up their end of the bargain in the shared responsibility model, as I've mentioned previously. And ultimately, we want to look at the susceptibility of our exposure in this space, understand our security posture, what we may need to do to enhance security monitoring and our capability to understand the telemetry of APIs from third parties being used in our environment in terms of our dependency and the supply chain roles in which they exist. We then look at, again, one of the things I've mentioned and touted is that we need to have logging and monitoring, but even without it, obviously we have exposure in the space. There is no awareness. There is no communication of that information through a reaction process to alert and respond in kind when we see effects that are contrary to our utility of respective APIs in the space. Becomes a security incident, which this can be challenging. It can often lead to, as mentioned here, this delayed or missed detection of threat. That becomes a huge issue when we have no idea. And, we can look at the Verizon data breach incident report and elements in that nature, looking at the time that organizations are compromised. That's not managed in hours or days, it's weeks and months. We have to have a lot better telemetry coming into the organization that we can make sense, provide informed decisions of response to these situations. We then look at misconfiguration. Obviously, we mentioned the hardened image as being that baseline approach that we want to look at cost management issues, looking at inefficiencies and unnecessary costs. We want to look at visibility and monitoring, allowing proper configuration to provide respective abilities to detect and respond to security incident. We look at inconsistency. We want to have that image, as it were, that hardened image used consistently, reduce that variability, reduce the complexity, reduce your risk. And then ultimately, inadequate disaster recovery is failure to configure robust abilities in this space. And where we see the cloud in its great utility is disaster recovery and backup solutions, where we can replicate information between systems across continents across the world, allows us a capability in this area. But without utilizing configuration in this space to have that robust ability to respond and have availability of information, obviously leads to significant data loss and downtime. We introduce emerging threats. These very common that we see these not only in the cloud space, but permeates all compute in any form or function. But we see the advanced persistent threat, right? We look at these APT actors. They have an ability, they are resource, they have an underlying understanding in some cases of our environment that allows them to extract information or cause harm. That's the long-term presence. This is not the short game. This is the long game. This is understanding the way businesses function, the underlying utility of certain products and services within cloud environments that are understood and then compromised. We look at cloud cryptojacking, unauthorized use of resources to basically mine cryptocurrency without necessarily the knowledge or consent of this cloud service user, allowing those resources to be used beyond the respective capacity which we're paying, but may gonna go unnoticed. If we don't have the telemetry, that logging, that monitoring, we may never know that this is occurring. And then we have the supply chain attacks in terms of the challenges in detection. We want to be able to understand where we have exposure to the supply chain, where we're reliant upon it, assess external entity, the complexity of those supply chains. Where our reliance exists is where our risk posture needs to address in kind and appropriate response to be able to monitor, manage our reliance in that area, understand where we have exposure. We lose, we go to then this financial loss, the lossy expectancy of direct and indirect breach costs, where we see regulatory fines. We have reputational damage in terms of trust and negative media attention. We also have to understand the legal and regulatory issues that we need to approach. So we have our risk cloud to the side here. These are elements we need to understand and look at the consequence of cloud security, or in a lot of cases, cloud insecurity. We need to understand those consequences because it affects our risk profile. Our risk profile should be contextualized to how we're utilizing our cloud infrastructure and provide protection mechanisms in this area. We look at our fundamental measures, right? We want to conform to recommended best practice that we utilize from conformance to the CIS benchmarks to help us stay secure, mitigate common threats of malware, denial of service, insufficient authorization, and overlapping trust boundary threats. We avoid misconfiguration because we've standardized, we've reached an approach that we're using hardened VM images to avoid this misconfiguration, and other instances where we can see human error or changes in the posture of our respective configuration. Monitoring configuration over time is essential. And then we offer evidence of compliance. So we utilize the hardened image, contain the final in the CIS Cat Pro assessor. This report ultimately produces and illustrates our compliance to the CIS benchmark, includes the necessity for hardened images to run in the cloud, and the report is integral to providing on-the-spot compliance evidence to show that our configuration is managed and controlled. We don't want variability in that space. Variability adds complexity, can lead to underlying issues in terms of the threats that we've mentioned. We then move to the consensus approach. So when we're developing benchmarks here at CIS, we have a community. We engage that community. We define the scope of what needs to be created in the underlying virtual image. We create the draft. We build a development process where we have input, review, consensus, discussion, adjustment that allows us to get to the consensus approach of providing best practice in these areas. Providing you hardened images, not just from one perspective, but many. And our volunteer community, absolutely essential for us to be able to provide the confidence in the hardened images, is providing you that baseline foundational layer of risk management and protection from security risks in the cloud. we look at bringing the community resources together. So it's the volunteer community. So we have the benchmark through the process, the cycle we just went through. Those are globally recognized. We have secure configuration leading us to the base operating system in the cloud. So those recommendations apply to the virtual image across the large cloud providers as displayed here. And then we have secure pre-configured images that meet the benchmarks, but that's not done without the volunteer community. It's essential to the process that we get the consensus, because we're stronger together. The stronger we are together, the better future for security we can create in that partnership. Ultimately, it goes without saying that we have partners in this space, and the guidance we provide is informed by amazing organizations and people across many different industries. Helps us build the consensus to cyber risk mitigation. Without the talents and expertise in the space, we're not able to provide the same level of veracity that we see in providing these images. Obviously, we thank Qualys at this point because with their unique insight and expertise, their regular participation across the major cloud platforms, the community calls that they answer, and they can provide reviews in the space like no other. They contribute to updates and recommendations across a number of different areas, highlighted here 2 specific examples, but really permeates our ability to provide these services and these capabilities to you with confidence. Ultimately, it leads us to resources. In this space, we have resources to help understand risk, responsibility, and capability. We have cloud foundation benchmarks. We have our hardened images. We have a beginner's guide to secure cloud configurations as displayed here on the left. And we encourage you to join the CIS Benchmarks community. Your input into that is essential for us to improve our underlying products and scope and breadth of understanding what is needed in the space to maintain that security. We have such a dynamic environment changing often that we need to be able to approach that with the consensus-based approach that is provided through our volunteer community. With that, I leave you with a few thoughts. We have risk management. We have the ability to monitor, engage, and representatively approach security through ultimately many different layers of processes through defense in depth. We want to manage those threats. We want to manage and mitigate that cyber risk as best we can to provide confidence in the compute that we use and the cloud services are secure and configured. We need to utilize a secure foundation. Utilizing the CIS hardened images provides an element of that foundation, building security into the process. And we can't do that without our community, without our partners in this space. And again, thank you to all of those who contribute. And for those joining, thank you for your future contributions to making cyber risk secured and controlled. And with that, I'd like to thank you and appreciate the time and opportunity to speak with you today.